Hello, welcome to a new session on JavaScript offered by Sifting Bytes Academy. My name is Venu and in today's session we will learn about how web works. We use JavaScript to develop websites or web applications. So, before we start to learn about JavaScript, it makes more sense to understand how websites work or how web works on a high level. We will do this by taking a simple example website and learn about what's happening behind the scenes when we browse through that website. Along the way, we will refine our grasp on few important terms and terminologies like Internet, World Wide Web, domain name, Uniform Resource Locator, HTTP and HTTPS protocols, DNS system, etc. I hope you find this session interesting and informative. So let's get started. Let's start by understanding the two most important terms, Internet and WWW, acronym for World Wide Web or in short, Web. Internet is a vast network of computers spread across all over the world. By connecting to this wide network, the Internet, people can share information and communicate with each other. So, if our goal is to share information and to communicate, then Internet is the means through which we can achieve this goal. Let's take an example to understand this better. Say we want to learn about Linux. We can simply go over the internet to find tons of information about it. Now there is an organized group of people who wanted to provide high quality, comprehensive and easily accessible information about Linux and other free software. So they started a project called the Linux Information Project. It's actually a website which we can browse through using a website address. All we need to do is type in the website address in the address bar of our browser. A website is an application which can be accessed using a web browser. Hence, it's also called as web application or in short, web app. Now this website is a very simple website developed using HTML, CSS and JavaScript, the three basic and most important web technologies to develop any website. HTML is a markup language using which we use tags to structure a web page, like the title of the web page, heading of a web page, content arranged in paragraphs, mixing them up with media files like images and videos. A web page is basically an HTML document, and a website can have one or more web pages. Now, cascading style sheets is a style sheet language used for describing the presentation of a HTML document, like providing text colors and styling fonts or providing background colors to HTML elements. Over time, CSS has evolved a lot and today we can do a lot more. It's used to develop responsive websites. And finally, JavaScript to make websites dynamic so that a user can actually interact with the website after it is displayed in the browser, like here using this button. It is possible for us to check out the source code of the website by clicking the right button on the mouse anywhere on the website and by selecting View Page Source from the drop-down. Here we can see HTML, CSS and JavaScript code of this website. All this is written by a web developer. And this is what a web developer does, especially a front-end web developer. In the plain sight, we are using a web browser installed in our computer to access this website. And there is another computer out there in internet which is providing us this website. Now this is a very simplistic view on how web works. But now we will dig a little deeper to understand what's happening behind the scenes in order for all this to work out. And most importantly, it helps us understand what's client-side programming and what is server-side programming. Every modern browser today, in addition to displaying or rendering web pages of websites, also provides something called developer tools or dev tools, which come in very handy for web developers. Along the course, we will be using Chrome web browser provided by Google, and we will explore all the features of these dev tools provided by Chrome. To open the developer console window on Chrome, we can open DevTools window by pressing the right click and selecting Inspect in the drop-down list. Or alternatively, we can use the keyboard shortcut Ctrl-Shift-J on Windows or Ctrl-Option-J on Mac OS. It might be different for other browsers, but the developer consoles look very similar across all browsers. So, if you pick up on learning DevTools of one browser, it's not much different on other ones. Let's take a step back to understand a client computer first. It could really be any device, a desktop, a laptop, or a mobile phone. Now say a person named Bob sitting in London has a desktop computer which at its core is made up of a set of physical components or hardware like CPU, RAM, hard disk, and other peripherals like monitor, keyboard, and a mouse, all connected to a motherboard. Now our focus is on Bob's computer here, and for visualization purpose, let's lay it out as layers as we go on. Now in order to access this hardware of his desktop computer, he needs to install a software called operating system on it. Operating system is a software layer which is effectively sitting on top of the hardware of the computer and acts as an interface between the user of the computer, that is Bob here, and the underlying hardware. Most operating systems provide two types of interfaces through which we can access our computer. A common one being a GUI, graphical user interface, meant for a normal general regular user like Bob, and a CLI for specialized users like developers. Specialized because one needs to know few commands to work with CLI, unlike in GUI where Bob can just use his mouse or touchpad to do all his work. For example, Windows operating system provides Windows graphical user interface and a CLI called command prompt. We need to know Windows commands to use this CLI. Similarly, Mac OS and Linux users should know Linux specific commands to work on their CLI, which is also called as terminal. Operating system can be classified as a system software because it allows us to access our system. Now in order to browse or access a website, Bob needs an additional special software called web browser. A web browser is a type of application software which is used for a specific application, here for browsing. Generally, operating system vendors provide some kind of web browsers bundled together with their operating system. For example, Microsoft provides Internet Explorer and Microsoft Edge bundled with their desktop class operating systems like Windows 10 or Windows 11. Similarly, Apple provides Safari with their Mac OS operating system. We can also install web browsers provided by third-party vendors like Chrome, which is provided by Google. When installed, it sits on top of the operating system. As a user of the computer, Bob here can run the web browser and type in the website address to open a website. So, an application software is a specialized software developed to serve specific needs of the user. Like we use a specialized software like web browser for a specific purpose of browsing a website, we can have a media player software, which is another kind of application software meant to play some media files lying in our system's hard disk. we can have application softwares like text editors, which we can use to read or edit our text files. The hardware layer of the computer is acting as a platform on which the operating system layer sits. And operating system layer is the platform on which application software sit. So the term platform is a relative term. For more detailed information on the platform and types of softwares, you can check out the link provided in the description below. Now Bob also wants to learn something about JavaScript, and just like we did earlier, he goes over the internet to find some information about it. So Bob, who is seeking for the information over the internet, is the client. He uses his desktop computer to connect to the internet, which becomes the client computer. To be more specific, he is using a specialized software web browser like Chrome, which becomes the client software or client application. A client really could mean a person or his computer or the application that he is using in his computer to browse a website in this case. But for all future references and purposes, by client, we mean the application that's being used to access the website. That is the web browser. On the other side is this organization who has the information on JavaScript and wants to share it to public. So, this organization, which is providing the service, can be called as a service provider, information service provider. They do it by putting all the information in their website. A website is a web application, or in short, also called as a web app, which can be accessed by general public by using a web browser. Now there are certain things the organization should be doing or should have done to make such a website available for public over the internet. First, they will have to develop a website using web technologies like HTML, CSS and JavaScript. A simple website or a web application like linfo.org is a collection of web pages with information stuffed into it. Such a website, where information in it does not change frequently and where there is hardly any possibility of user interaction other than clicking on a bunch of links provided, is called a static website or a static web application. It's a good place to start with, so we will build and develop a similar simple static website in the next video to understand development firsthand. After development of website, they need a computer to deploy or host this web application. The computer this organization uses is called as a server. Basically another computer with high-end hardware configuration of server class, which is generally more robust and expensive than the consumer class hardware that's in Bob's computer. Just like we did it for client computer, we will focus now on this server computer and lay out the layers of it for visualization purpose. A server also, at its core, is made up of a set of physical components or hardware, CPU, RAM, hard disk, etc. To make this enterprise class hardware usable, there is an operating system installed on top of it, which is again a server class operating system, which is a more specialized and robust operating system when compared to the desktop class operating system in Bob's computer. Since this server computer is used for hosting a website, it's also commonly referred to as a host. Generally, operating system vendors develop and provide various classes of operating systems. For example, Microsoft develops and provides desktop operating systems like Windows 8, 10, 11 to be used on general purpose computers used by general consumers like Bob. It also develops special server operating systems like Windows Server 2022 to be used on special purpose computers like servers. They also develop other classes of operating systems like for mobile phones, embedded systems and IoT devices. Apple also does the same. It provides macOS for desktop users, macOS Server for servers, iOS for iPhones, watchOS for their smartwatches and so on. Going back to our visual representation of server, there is a need for an additional software on top of this operating system in order to configure this server as a web server. On configuring a server as a web server, it becomes a super specialized server that excels in serving websites or web applications to clients. This web server application installed on server computer is actually the one that responds back to the clients by sending the requested files or resources. Now, the type of web server software that needs to be installed depends on the technology stack one has adopted to develop their web application. While HTML, CSS and JavaScript are commonly used front-end technologies in all web applications, as is the case of a simple static website like linfo.org. It's just a collection or bunch of static files, HTML files using a bit of CSS styling and a little bit of JavaScript for this button functionality. For this, any web server software works. On proper configuration, web server software just picks up these raw static HTML, CSS and JavaScript files lying in the disk space of the server computer and sends it across over the network to the client's computer. Writing JavaScript code embedded and written inline within script tag of the HTML pages or linked to HTML pages using source attribute in the script tag is client-side programming. Because this raw JavaScript program code, which is sent by the web server along with HTML and CSS, is executed and run by the client application, that is the browser. When the client application, that is the web browser software installed on the client computer, an application which has components like HTML parser, CSS parser and JavaScript engine, translate and run all this code. But in complex applications, where it involves database interactions and stuff, we might need server-side technologies as well, which are developed using server-side programming languages like Java, PHP or Python. The code written for this purpose is actually executed on the server. Hence, it's called server-side programming. Now, if Java is used, then one can install web server softwares like Apache Tomcat or Oracle's WebLogic, which excel in serving Java-based web applications. If PHP is used, then one can go with the XAMPP server or a WAMP server. Now here comes the most interesting part. With the advent and rise in popularity of Node.js, which is a JavaScript-based server-side technology, we can use JavaScript as a server-side programming language. So, you learn one language and will be good to go to do both client-side programming and server-side programming as well. A person who can write just front-end code is a front-end web developer. A front-end developer should know HTML, CSS and JavaScript. And who can just write back-end code by using JavaScript is a back-end developer. And one who can do both is a full-stack developer. Of course, a full-stack developer today is supposed to know deployment strategies as well. We will dive deeper into these things later, where you'll understand what they really are. Now that we have a clear idea on a client computer and the server computer, let's see how this client-server communication happens over the internet. So, on one side, there is Bob's computer somewhere in London connected to the internet, and on the other side, there is this linfo.org web server, say in Pennsylvania, also connected to the internet. Every computer connected to the internet needs a unique IP address in order to physically locate and communicate with each other. An IP address is pretty much analogous to a person's home address. It's got to be unique in order to locate that person wherever the person is in the world. IP address stands for Internet Protocol Address. An IP version 4 looks something like this, or a more modern IP version 6 looks something like this. It's a good idea to explore and learn a little bit more about these versions in detail as IPv6 is the future. Maybe I'll make a separate video on it and I'll share the link in the description once I do. But for this video, let's stick with IPv4 just for convenience sake, as it takes lesser number of characters and therefore lesser screen space. So, we have a unique IP address for the Bob's computer and also a unique IP address for the web server. Now let's say Bob wants to learn a little bit of JavaScript and wants to check out another yet very resourceful and popular website, W3 Schools. If Bob knows the IP address of the W3 Schools web server, and let's assume he does, then he can directly type in the IP address in the address bar of his web browser. And when he does, his client application, the web browser, be it a Chrome or Mozilla's Firefox, it will send a message to the server requesting for the website. The server, on receiving the message, will respond back with a message that contains a web page of the website. But remembering the IP addresses of every website we would want to check out is not practically feasible. Humans are more accustomed to remember meaningful names rather than just a string of numbers. So, we have something called domain names for websites. Every public website has a unique domain name using which we can access the website. So Bob can just type in the domain name of the website, W3 Schools, in the address bar of the browser instead of the IP address of the web server. And if we closely notice the address bar, browser does few things before sending a message to the server. The first thing it prepends is a default subdomain name, that is www. When W3 Schools bought and registered this domain name, w3schools.com, www is the default subdomain it comes with. In addition to this default subdomain, they can have other subdomains if they wish to. Like for a blog, they can have blog.w3schools.com, or for documentation, they can have docs.w3schools.com, etc. It also prepends it with HTTP or HTTPS. HTTP stands for Hypertext Transfer Protocol, which is just a standard way the web browsers and web servers communicate with each other. We will learn more about it in the course. But for now, let's say this message sent by the web browser is formatted in a particular manner as defined by HTTP standard. This HTTP message contains information required for the web server to listen and respond back. It is a combination of some metadata in the form of headers and the user inputs data if we are sending across any data like username and password wrapped up in the body of the message. This HTTP message is called a HTTP request, or in short, a request. Browser also appends something called a port number. Here it's 80, which is the default for HTTP protocol, or 443, which is the default port number for HTTPS protocol. So, the W3 Schools web server receives and listens to this request through its port 80 or 443, does some basic validation and responds back with a HTTP message, and we can call this HTTP response, or in short, a response. This response message is also formatted as per HTTP protocol standard. It has headers which contain metadata and a body which can contain all sorts of resources, data resources. It could be a simple text data, XML data, or JSON data, media files, or HTML data. If it has the HTML document data, it will be rendered onto the browser's window. We will look at the other forms of data and all forms of resources later in the tutorial. In a nutshell, this is how the web browser, which is a common client application, and a web server communicate with each other over a network. And such various client computers and server computers scattered across the internet, which enable such sharing of web resources, make it a World Wide Web, or in short, web. Now there is more to it than what we have seen. Let's build a little bit more on what we have learned till now. If Bob is using a domain name, how does Bob's computer know the location of the W3 School's web server in the network? As mentioned earlier, a computer can locate another computer over a network only if it knows the IP address of the computer, which is unique across the network. So here's what happens. When Bob enters the domain name w3schools.com for the first time in his browser, he gets some help. He gets help from something called DNS System, which stands for Domain Name System. It's an elaborate network of DNS servers collectively working together to resolve the domain name Bob enters in the browser to the actual IP address of the respective server. We will explore more about this DNS system in detail down the line, but for the sake of this video, think of it as some system which maintains a lookup table that has a list of registered domain names of host servers and the public IP addresses they are configured with. Now that we know all the systems are connected through the internet, let's clear up some screen space. When Bob enters the domain name w3schools.com for the first time, the browser automatically sends a DNS lookup request to this DNS system. Now the question is, how does Bob's browser know where the DNS server is in the first place? It knows because the DNS system server's details are pre-configured into the internet network settings in the Bob's computer. This DNS system, which maintains a lookup table, matches the domain name with the public IP address. Obviously, W3 Schools people, after hosting their website in a server, would have registered their domain name and their IP address with DNS. If the DNS system finds a mapping IP address, it returns it to the Bob's computer. Bob's browser caches it or stores it locally for future references and sends a HTTP request to that noted IP address. From here on, the client-server communication continues as discussed earlier. We have learnt a little bit about HTTP earlier, but what's HTTPS and how is it different from HTTP? Let's take the two example websites which we have accessed in this tutorial, linfo.org and w3schools.com. Let's check out linfo.org first. When we try to access the website, notice the warning here which says not secure. On clicking on it, you will see a full warning message which says that our connection to this site is not secure. In simple words, it means whatever data is sent through HTTP messages over the network from either client to server or from server to client is not safe. Hackers can peek into the data when it is in transit, because data packets hop over and travel through a series of computers, actually routers, before it reaches the final destination. This could lead to eavesdropping, data theft and message forgery. Now HTTPS is a solution to this problem. It stands for Hypertext Transfer Protocol Secure, which is basically an extension of HTTP. It is used for secure communication over a network and is widely used on the internet. Like in the case of the website w3schools.com. We can see a padlock icon here indicating that the connection to this website is secured. That is, this website is configured and secured with transport layer security, in short TLS, which is a more advanced version of the earlier SSL that enables a more secure connection. That is, HTTPS is enabled for communication with the clients. Now, without getting too much deeper into it, TLS and SSL are a kind of server-side digital certificates that provide a data encryption mechanism with a set of public key and a private key called key pairs. the server keeps the private key and issues public key to the client. We will discuss about it in more detail later. But for now, in simple terms, the general communication procedure in HTTPS is more or less same as HTTP, except that the messages, that is, request and response messages, which contain data and metadata, are encrypted. So, a request message is encrypted with a public key at the client side and sent over the network. On receiving the message, the server decrypts the message with the private key it has and uses it. Similarly, a response is encrypted with the private key and sent over the network, which is then decrypted by the client by the public key it has on receiving the response. This way, if someone tries to sniff or eavesdrop while the data messages are in transit, they might be successful in reading the data, but it's in an encrypted format, which is not useful for the hacker. This bidirectional encryption of communications between a client and server protects the communications against man-in-the-middle attacks. This protocol is therefore also referred to as HTTP over TLS or HTTP over SSL. We will see all these concepts in action as we go on in the course. Well, that's all for now. See you in the next one. Your feedback will be enormously helpful in improvising the final shape of this course. So please subscribe to the Sifting Bytes channel and contribute any questions, comments or suggestions in the comment section below. Thank you.